Okay,
You can start now.
okay. Thank you. Thank you for giving me this opportunity. Today I will present one of our research performed by me and Hamza Ghaddar from University of Jijel and Sid Ahmed Touil from University Institute of Electrical and Electronic Engineering, Bomardas, concerned under the title Estimation of Surface Cracks in Ferromagnetic Material based on EMAT signal and machine learning algorithms. For that, I established this outline. First, I will start by an introduction general about the EMAT techniques. Next, I will present the main configuration of EMAT sensor and its operating principle. Then the mathematical formulation of the electromagnetic acoustic problem, following by the modeling of EMAT sensor using finite element method implemented in COMSOL software. Finally, we use the EMAT sensor to detect surface crack and the characterization of this crack using by solving the inverse problems using an SVM techniques. So EMAT is an ultrasonic technique, entity technique that used for applied for conductive material is a non-contact techniques used to detect intern and surface cracks in conductive material. The last research concern of EMAT sensor focus to solve to detect and improve the efficiency of the sensor, but the quantitative of defect size is rest an issue must be solved, and that we are try to solve in this research by the solving of the inverse problem. But sensor, the main principal configuration is composed by permanent magnets and conductive coil placed above a material under test. The principal configuration is by the generation of the Lorentz force inside the conductive material. This force is a result by the interaction of the static magnetic and the induced current at the surface of the material. The receiving of this force introduce vibration, which means ultrasonic propagates above the material. We can receive and pick up these waves by the inverse model of electromagnetic model. The mathematical formulation is formulated by the performance of Maxwell equation and the milieu laws, compartments of the medium to perform the partial differential equation, which is solved by la méthode des éléments finis. For the acoustic model, we use the Newton laws and the relation of deformation and displacement to formulate the Navi equation, which explained by the following the equation. To solve the precedence equation, we are use the COMSOL multi-field method des éléments finis implemented in the COMSOL multi-physics. After the introduction of the geometry and the property physics, we solved the problem to evaluate the potential vector and the ultrasonic field. This is the configuration that we are used and implemented in the console. Is the same for the transmitter and the receiver. We are evaluate the following physical parameter: magnetics and eddy current, Lorentz force, and mechanical displacement. You can see this figure present the Lorentz force generated at the surface of material, which results by the interaction of the eddy current and the magnetic field in the x direction and the y direction of the geometry. Figure present the ultrasonic waves. We can distinguish all these Rayleigh waves, shear vertical and longitudinal waves at different times. This result show the efficiency of the EMAT sensor to detect the variation in the surface defects. This result will be used to solve the inverse problem from the received signal. As we are President, the resolution of the inverse problem will start from the measured signal of unknown defect. There are two methods used to solve inverse problem: iterative inversion using iterative algorithm, and direct inversion with the regression or classification method. According to the nature of our problem, we are use LSVM techniques to find the relation between the received signal and the parameter of dimension of defects. Before start the resolution of the inverse model, we need to build a database to feed the inverse model. Is created by numerically solving of the direct problem. This database consists of two sets. The set of the defects corresponding of each measured signal, and the second is the voltage measured by the EMAT. This database is performed by the combination of two software, the console, multiphysics, and MATLAB. We need to evaluate some parameter to evaluate and assess our efficiency of our inverse model. Finally, we can see the result. We can see that the points of each figure for the profondeur and the larger of the defect, the points in each figure are clustered around the straight line with the same slope, which means that the estimated defect size are almost equal to the desired one. Moreover, we obtain the result in table show very value of the RMSU, and which indicates an inverse model has very good reduction accuracy. Thank you for your time and consideration.